Good morning, everybody. Let's get started. So welcome to Virtual Global Health Week, sponsored by the Consortium of Universities for Global Health. I'm Philip Landrigan, and I direct the program for Global Public Health and the Common Good at Boston College. Also, I served the last year or so as chair of the Minderoo-Monaco Commission on Plastics and Human Health. And I'm joined this morning by a series of distinguished scientists who were all members of that Minderoo-Monaco Commission, which was sponsored jointly by the Minderoo Foundation of Australia and by the Prince Albert II of Monaco Foundation in Monaco. So our first speaker is Dr. Sarah Dunlop. Sarah is calling in from Perth, Western Australia. She is a former chancellor of the University of Western Australia and now a senior scientist at the Minderoo Foundation. And she's going to kick us off by explaining why we undertook this study and how we put it together. Then I'll follow her. I'll talk about the health effects of plastic, and then either I or my colleague Hervé Raps, one or the other of us, depending if Hervé comes on. We'll talk about the hazards of plastic in the marine environment, which I think is all too familiar, unfortunately, to all of us. Then Dr. Maureen Cropper of the University of Maryland will talk, who is an economist, professor of economics and chair of the economics department at Maryland. We'll talk about the health-related costs of plastic. Then will come Dr. Adatun Mustafa from Nigeria, speaking about global environmental justice, the disproportionate impacts of plastics in low-income and middle-income countries, which I suspect will be a topic of great interest to this audience. And then finally, we'll talk about the prospects for a UN global plastics treaty. And that will probably, depending on who joins us, it'll probably be Dr. Dunlop, and I will take the lead on that. So without further ado, I'm going to hand this over to Dr. Sarah Dunlop of Australia, who will set the table for us. Sarah?
Thanks so much, Phil, for your introduction. So I was in academia for quite some time, and then I joined Minderoo Foundation in Australia here. And that's a philanthropic organization that really is seeking a fairer world, and by valuing all people and ecosystems. And what I'm going to do, first slide, please, is going to be shared for me by someone on the team. We don't have that yet. Thank you, Sarika, thank you. So I'm going to be talking about the Minderoo-Monaco Commission and how it came about, and also having a sort of overview of what we mean by the plastic life cycle. So the next slide, please, Sarika. And you don't really have to look very far at all to see really distressing images about the total overwhelm of the environment and everything living in it by plastic. There's a whale on the left, that's a river in the center. On the right, we have a young child, a waste picker, a plastic waste picker. And although awareness about visible environmental pollution, I think that's certainly increasing, that awareness has done nothing really to curb the problem or to stop it. And I think, and we all do here in the Commission, that a missing element in the fight, and I think it is a fight, to stop the harm that plastic's having on the environment, is to be totally selfish and think about our own health and what it's doing to us. And ourselves, as well as other people around the world, posit that human health really should urgently be put centerfold in this problem and spotlight our own health to act as a really urgently needed catalyst to stop the escalating harm from this pollution. So next slide, please. Just as in clinical care, where primary prevention is the most effective form of medical treatment, for plastic pollution, we also need to go to the source. Where does it come from? And we also need to understand the entire life cycle, from beginning right to end. And Also, what else should we worry about? What else should we worry about? Does it impact us? And if so, how? And really what's going on. So putting those two things together, the life cycle and the harm it does to us as humans, that was the real combined driver that helped us form the Mindry-Monaco Commission. Next slide, please. So in the words of one of our co-founders, Nicola Forrest, and it's headed up by Andrew as well, Andrew Forrest, who's a mining magnate in this country, we formed a core team, and Christos Simonides is a pediatrician as part of the plastics team, and I'm a scientist, and I'm the senior author on this commission. Of course, we have Phil Landrigan, who chaired the commission, and Hervé Raps from the Centre Scientifique de Monaco, and he was really linking the context for both the ocean and the human health. Next slide, please. So we did what we needed to do, and that was to gather a stellar team of about 48 international scientists, and we gave ourselves 1 year to pull this thing together. And it was launched, it seems like a long time ago now, but it was actually March this year in Monaco during Monaco Ocean Week. And I've highlighted the authors there that will be speaking today. So next slide, please. To answer the question, where does it come from? Well, it comes from fossil fuel. But the complex reality is that there are multiple health impacts, which you're going to hear about later, particularly from Phil. So 99% of plastic comes from fossil fuel, 2/3 globally from coal, and the remainder from oil and gas. And, if conventional fossil fuel extraction wasn't enough, we're still at it. And we're doing something called unconventional fossil fuel extraction, called fracking, which is short for hydraulic fracturing in engineering jargon. And the bottom right is a map of the world of explored so-called resources. And just to give you an idea, in the United States alone, they've already drilled by 2019 52,000 fracking wells. It's an enormous enterprise. Next slide, please. So on the left, we have something called an ethane cracker. And it's called a cracker because it splits up the very large molecules in crude oil and coal and gas, and breaks it down into much smaller molecules, which use as starting blocks to make plastic. And again, this is a massive investment. Each one of these crackers costs about $1 billion US, and there's a plan, I think it's already being built now, to build a $6 billion cracker in Pennsylvania. And the bottom graph on the right really tells the story. Fossil fuel production is peaking over now in the next decade, but the issue is that the fossil fuel industry is now, as renewable energy sources come in, they are replacing the fossil fuels by starting to pivot away from fossil fuels for energy, to start using that fossil fuel plastic to make the fossil fuel to make even more plastic. So in 2014, about 4 to 6% of fossil fuel was made to make plastic, and this is predicted to increase to a staggering 20% of all fossil fuel by 2050. And whichever way you look at it, the numbers are absolutely staggering. So we started off in the 1950s with about 2 million metric tons per annum, and that has increased to 460 million tons per annum today. The increase is exponential, with over half of this increase occurring since 2002. And by 2015, we produced 8 billion metric tons. That's 1 ton for every person on the planet. And 1 ton is equivalent in, if you'd like to visualize it, for a Volkswagen Beetle car. We're tracking towards 35 gigatons of plastic by, let's say, 34 billion tons of plastic by 2050. And 1 gigaton is roughly equivalent to 10,000 fully laden US aircraft carriers. So a lot of plastic. Now, I've talked about fossil fuel extraction. If we could have the next slide, please. And I've got fracking on the left. It does deserve a special mention because it's a chemically intensive process, over 1,000 chemicals identified, many highly toxic. And not only that, but it's also very water intensive. So the chemicals are added to the water and pumped into the ground. And it's roughly about 20,000 kilograms of chemicals are added per frac well. And on the right, you've got just some of the toxic chemicals, many known carcinogens, neurotoxicants, and endocrine disruptors, which are involved in the production during the extraction of fossil fuels, as well as during fracking. So it's a toxic business. And the next slide is really to do with this issue about plastic. Actually, if we could just duck back to the previous slide, please, Sarika, that would be great. Thank you. At the bottom right here, it's energy intensive, but there's a lot of greenhouse gas being emitted as well as particulate matter, and you'll hear more about that later on. But the next slide, please, just shows you the extent of the, if I could have the next slide, please, Sarika. Thank you. The extent of the greenhouse gas emissions. And it was about 2 gigatons in 2015, and that's equivalent to Russia. And with the predicted increases in fossil fuel production, it's only going to go up. So another problem there. Next slide, please, Sarika. So what is plastic? Well, it is a complex mixture of compounded chemicals. And there are two very broad chemical classes, starting materials. There's the monomers and the additives. And the monomers, for example, ethylene and propylene are polymerized into long chains of repeating monomers. So polyethylene, polypropylene. But these long chains are absolutely useless on their own. And to make plastic, you have to add a wide variety of additives to confer flexibility from plasticizers, flame resistance from flame retardants, and then stability to stop the stuff breaking down while it's exposed to light, UV, and heat. And there's a truckload more chemicals, stabilizers, antioxidants, colorants, etc., as well as catalysts, fillers, foaming agents, you name it. The list is endless. And we know there are about 10,500 to 13,000 chemicals in total. Many are known to be harmful. However, there are many that have never been tested and for which there are no reported hazard classifications. And also there's absolutely zero disclosure. And we don't know which chemicals are in which products. And so we're totally flying blind. So the next slide, please. After production, the next phase of the life cycle is use. And we have to admit that plastic has been an incredible success story in terms of its material properties. It's light, it's strong, it's soft, hard, flexible, colorful, colored, durable, whatever you want. And it's used in every aspect of our lives. You just try and, imagine a day without it. So, drink bottles to furnishings, cars, fridges, even the Dreamliner aircraft is about 50% composite plastic materials. Turns out that single-use plastics, those things we use once and then toss away, are actually 35 to 40% of the market. And that's followed by, interestingly, synthetic fibers, a huge contribution. That we're wearing plastic. And then there's the building and construction materials, the transport, the agriculture, and of course the medical use of plastic. And modern medicine wouldn't be what it is without that today. So incredible utility, but not the wisest design. And why is that? Okay. So next slide, please. From a health perspective, there are two major problems with plastic. The first is that it fragments into smaller and smaller pieces of itself. And we're beginning to learn that microplastics are in us. There's a list of organs where we think that is the case. But it's really unknown how far the much smaller nanoplastics, right down to the, the sort of 20 to 100 nanometer level, are really getting into us. We just don't know. And that's because the sample contamination and technical issues mean that so far it's proved very hard to accurately measure plastic exposure inside humans. And until we can do that, we can't really do the epidemiological studies. But there's plenty of evidence for real concern. For example, textile workers have extensive sorts of lung disease, stomach and esophageal cancer. But for everyday exposure, the jury is out on health impacts. But the other thing I think we need to take note of is that we are potentially sitting on a massive toxic debt, because every single piece of plastic that's in the environment, its destiny is to break up into smaller and smaller micro and nanoplastics, which will get into both the environment and eventually us. Next slide, please, Sarika. So the other problem is that chemicals leach out of plastic. All those chemicals I mentioned are not covalently bonded to the polymers. They leach out, as do the unleached monomers. And we know those chemicals get into us because everywhere we look, we find them. So seminal fluid, follicular fluid, amniotic fluid, cord blood, urine, soft tissues, it's all there. And with multiple health consequences, and you will hear about this from Phil shortly. So two major problems with plastic, the micro and nanoplastics, as well as the chemical impost from the product itself, and all of the chemical releases that occur during the production phase, as well as the disposal phase of plastic. So if I can move to the next slide, please. This now shows the full life cycle. Now I'll talk briefly about the disposal on the right and make the point that we've put recycling into disposal, because really everything in this diagram is going from left to right. There's very little that's circular about this life cycle. It's all going from use to the environment and then into us. And why has recycling been such a failure? Well, there are a number of reasons. The material itself, as I've described, has these problems. There's very unfavorable economics because of the cost of collection and transport and sorting, and the low value of the plastic itself. The sorting and multi-layered products are a major issue. And also plastic films can't be recycled. And there's extensive use of materials which have virtually zero value. So sachets and the such like, and we just throw them away. And you've got to remember, I've mentioned all of these toxic chemicals that are in the plastic itself. Well, guess what? When you recycle it, you've still got the toxic chemicals in there. In fact, the evidence is coming through that there are increased numbers of toxic chemicals in recycled plastic compared to virgin. And because of this issue, you can see that only about 10% of the plastic there is actually recycled globally. But only 1% of that 10% is true recycling, i.e. on par, which means for example, bottle to bottle. Most of it is downcycling from one type of product to an inferior product and of lower value. And for the single-use plastics, the other work that's been done at Mindru has shown that only about 1% of single-use plastics is recycled. So mostly we're using this stuff and tossing it out into the environment, at least 2/3 of it, since this vast amount was ever produced. So what isn't recycled then actually ends up either ended up in landfill, either controlled municipal landfill or uncontrolled dumps in countries which just don't have the infrastructure to deal with this amount of pollution, or it gets burnt, and that can be controlled or uncontrolled open burning, which is extremely toxic because that itself produces a wide range of extremely nasty chemicals, including dioxins. I mean, that's one of the worst, I think Agent Orange, and one of the worst carcinogens and causing severe birth defects. So we have a problem. The life cycle is long, it's complex, it's far from circular, and we see harms to the human and ocean health throughout that life cycle. And if I go to the last slide, please, Sarika. Plastic, so it comes from fossil fuel. And we desperately need an alternative so we can pivot away from the fossil fuel material, which is toxic. And the what else should be worried about question, well, it's not just the visible pollution, it's the invisible pollution, which I've started to articulate. And also the very clear message that plastic pollution is not just a waste issue, it's also a health issue. And Phil will now talk about the health issues across the plastic life cycle. We'll be hearing, I think, about damages to the ocean, which is the sink. It's the last resort where a lot of it ends up. Maureen Cropper and Hervé Raps from the Centre Scientifique de Monaco will be talking about that. Maureen Cropper will tell us about the incredibly high health costs that we're discovering on this, and then the utter shame, really, of the social and environmental injustice, as I've called it there, which Adatun Mustafa will be talking about. Now, that's the problem definition, and what we desperately need are solutions, and we need them now. And one of those, of course, is the United Nations Global Plastics Treaty, and we hope to discuss that as well at the end of this presentation. So, Phil, I think I now hand to you, and thank you so much, Sarika, for advancing those slides.
Thank you, Sarah, and I'm now going to share my screen. I'd be good at this after 3 years of COVID. Sorry. Okay, are you showing? Okay, is that displaying properly now? Sarika,
Yes.
can you tell me?
Yes.
Okay. So, yeah, so I'm going to continue following on Sarah's presentation, and let me begin by setting the context, because I think people are not aware, most people are not aware of just how much plastic is in the world and how rapidly plastic production is increasing. So plastics date back to the late 1900s, but they really didn't come onto the commercial market until after World War II. And back in the 1950s, about 2 million metric tons were produced per year. Since that time, plastic production has grown more than 200-fold, and we're now producing about 450 million metric tons per year. The total production since 1950 is 8 gigatons, 8 trillion tons. As Sarah has already said, virtually all of this comes from fossil carbon, from coal, from oil, from gas. Production is energy intensive and produces large amounts of greenhouse gases, which are greater than the contribution of either Brazil or Russia. Production, here's the real kicker. Production is accelerating. It's on track to double by 2040 and triple by 2060. A very great portion and an increasing portion is single-use plastic. Let me digress for a second and explain why plastic production is increasing so much. Basically, goes back to the fossil fuel industry. The fossil fuel industry is a vertically integrated industry, which means that the same companies that extract coal and oil from gas from the ground are the companies that make plastic. These companies are confronted by two realities. The market for burning fossil carbon, for burning coal, for burning gas, for burning oil is going down. Not as rapidly as we would like, but as the world goes green and switches to renewable energy, the market for burning fossil carbon is diminishing. At the same time, these companies are sitting on vast reserves of fossil fuel that they pulled out with modern day techniques like fracking. So they need to find a way to sell their product. They've got large quantities of fossil fuel. Their traditional markets are declining, and they're pivoting, and they're transitioning to the production of plastic. And that's what's driving this great increase in plastic production. And that's why the production of single-use plastic is such a goldmine for the fossil fuel industry, because stuff is used once, it's thrown away, and therefore, of course, there's a continuing need for more and more of it. Think of all the things in your life that even 5 years ago were handled by paper, like takeout food, and it now comes in plastic. As Sarah has said, a very low fraction of plastic is recycled. That contrasts with 75% of paper and glass, aluminum, cardboard. And it's not because people aren't conscientious, they are. It's that plastic resists recycling. The different polymers cannot be commingled to make recycled products. And because plastics contain hundreds of toxic chemicals, the recycled plastic can't be used for things like food wrapping or clothing or children's toys because it's full of toxic chemicals. And finally, plastic is persistent. It doesn't break down very much in the environment. It breaks down into smaller particles, but it doesn't go away. It doesn't turn into small molecules. And consequently, 6 gigatons of the 8 ever made, so 75% of the plastic ever made, now is in the environment and pollutes the environment. And that's only going to get worse as production continues to increase and as recycling rates remain very low. Sarah has traced the plastic life cycle for you. Let me amplify or follow on her message and present the evidence that at each stage of this life cycle, in production, in use, in disposal, plastic causes harm to human health. And many of these harms are due to the chemicals that are in plastics that Sarah has talked about. They affect production workers, people who live in fence-line communities, all of us who use plastic, and people who are exposed to plastic waste. And don't think of waste plastics as just inert materials. They're not. They're actually Trojan horses. They contain all of the toxic chemicals that are contained in plastic. So here's fracking. Fracking wells are enormous structures, incredibly disruptive to ecosystems, incredibly disruptive to the small rural communities where they're situated. And fracking, transport, fossil fuel, the transformation of fossil fuels in plastics, all of these processes that are outlined on the left-hand side of this slide cause a huge range of diseases to plastic workers. So those down at the bottom here who are extracting oil and gas, or those up here who are mining coal, are exposed to physical injury, lung disease, heart disease, stroke. Production workers are exposed to a soup of chemicals in cracking plants like that plant that Sarah just showed you, and are at high risk of cancer, reproductive problems, neurotoxicity. People who lived along pipelines, people who live along rail lines, think of people in the USA and East Palestine, Ohio, are exposed to burns, injuries, and traumatic death. And then workers over here on the right-hand side in recycling are exposed to all the chemicals of plastic production workers, and they're exposed also to the toxic chemicals such as dioxin that are formed when plastics are recycled. The chemicals in plastic production do not stay in the factories. They spill over the fences. They go into the nearby communities called fence-line communities. They cause many of the same diseases that we see in the plastic workers, but the difference is that these populations are different. Instead of being composed only of industrial workers, they also contain infants, pregnant women, the elderly. And so we see things like childhood asthma, low birth weight, premature birth, childhood leukemia coming up in fence-line populations. And of course, fence-line populations are typically low income, minority, marginalized, indigenous people. And so social injustice, which Atatun will talk about in a few minutes, is pervasive in these communities. What about plastic users, which is all of us and especially our kids? Well, all of the chemicals that are in plastic don't stay in plastic. For the most part, they're not chemically bound to the polymer matrix. They're just stuck in there. And so when plastic is handled, when it's heated, when kids play with it, those chemicals leach out. They get onto children's hands. They get swallowed. Many of them are endocrine disruptors and cause the range of problems that are shown here. The microplastics get into the human body, and their toxicity is still being unraveled. But we know that they carry with them toxic chemicals, and there's evidence that they may increase risk of cardiovascular disease and stroke. I'm a pediatrician, and so I always feel compelled to talk about the particular hazards of plastics to pregnant women, infants in the womb and young children. And one of the things we've learned from after chemical starting many years ago with lead is that during pregnancy, even very, very low levels of toxic chemicals can cause terrible damage to infants, especially during pregnancy. And the consequences are brain damage, birth defects, and cancer. The brain damage can show up as decreased IQ, autism, ADHD. We've learned the hard way that there are no such thing as safe exposure thresholds in prenatal life. The effects can last lifelong, and the only rational way to keep these problems from happening is to prevent exposure in the first place, primary prevention. So the time has come when we must act, and this was the conclusion of the Minderoo-Monaco Commission. We acknowledge that there's much that we don't know about plastic. There are huge gaps in our knowledge. We don't know nearly enough, for example, about the health effects of microplastics. But we know very clearly that plastics' harms to human health and the global environment are serious. And we know that in the absence of urgent intervention, these harms are going to get worse. We cannot do what the fossil fuel industry would like us to do and wait until we have complete information before we act. Because if we wait until we have complete information, we will lose years, we will lose decades, and we'll poison thousands, even millions of people. And so our commission argued that the world's nations must urgently come together to develop a legally binding global plastics treaty. We'll talk more about this at the end of the talk. That we believe that this treaty needs to include a global cap on plastic. Somebody's got a dog, they might want to mute. A global cap on plastic production. And the treaty needs to look at all the thousands of chemicals that are in plastics, not just the polymers themselves, but also the additive chemicals. And it has to require pre-market testing, simplification, health protective standards, increased transparency in regard to these chemicals. So thank you there for that. So Hervé, are you on? If not, I can give Hervé's talk on plastics and human health. Plastics and ocean health. This was put together by Dr. Hervé Raps of the Scientific Centers from Monaco, and also included in the presentation are some slides from our colleagues, Drs. John Stegeman and Mark Hahn, who are from the Woods Hole Oceanographic Institution in Woods Hole, Massachusetts. So what about the oceans? Well, I thought I'd start with this quote from Arthur C. Clarke, the famous science fiction writer, who said poignantly, how inappropriate it is to call this planet Earth when it is quite clearly ocean, as you can see from the space. So the oceans cover 72% of the Earth's surface. They are incredibly important to the sustenance of all life on Earth. The oceans produce half of the oxygen that we breathe each year, and 70% of all the oxygen that has ever been released to the atmosphere is generated by microorganisms in the ocean, mostly blue-green algae. The oceans are vital to stabilizing the global climate. They absorb 25% of all the carbon dioxide that is emitted into the atmosphere. They absorb 90% of all the heat, the excess heat that we release into the atmosphere. Without the oceans, the planet would burn up. The oceans feed something like 40% of humanity. 3 billion people depend on the ocean for food and for livelihood. And of course, the oceans are a source of peace and joy and recreation for so many of us. But the oceans are under threat, and it's mainly human activity, of course, that's the source of this threat. Sea surface temperatures are rising in consequence of the fact that the ocean is absorbing heat, and glaciers are melting. Rising seas increasingly threaten people who live near the sea, which is about 40% of the world's population. As the sea gets warmer, harmful algal species and pathogenic bacteria like Vibrio are migrating into cold, previously uncontaminated waters. The ocean is acidifying, it's losing oxygen, fish stocks are declining, and all sorts of reckless human activities threaten the sustainability of the oceans, most especially pollution. So plastic leaks out into the environment and into the ocean at every stage of the plastic life cycle, as is shown here, in production, in use, and in disposal. And about 10 to 12 million tons of plastic enters the ocean every year, 80% of it from land, coastal runoff, rivers, sediments. And the major drivers are the incredible increase in plastic production that I showed in that slide a few minutes ago, and the simultaneous increase in production of manufactured chemicals and pesticides. Chemical production is expected to double in the next 25 years, so pretty much on pace with plastic production. And uncontrolled development along the world's coasts is a further cause of plastic pollution of the ocean. So when plastic gets into the ocean, it typically enters it in the form of macroplastics, visible plastics like fish nets, 55-gallon drums, detergent bottles, soft drink bottles, and so on. And here's a haunting picture of a turtle trapped in a fish net. You saw the picture on Sarah's first slide of the whale whose gastrointestinal tract was filled with plastic. These are powerful images, and I think they've mobilized action around the world, concern for the ocean. But plastics are also break down into microplastics in the ocean. When the plastic comes from the land, comes out of ships, gets into the ocean, it breaks down. The marine environment is a harsh environment. There's wind, there's weather, there's changes in temperature, and the macroplastics break down into microplastics and then into nanoplastics. And these nanoplastics sink to the bottom of the sea. They contaminate the sea surface from the ocean from the sea surface down to the ocean depths and in every corner of the world. And some of these microplastics get into the food chain. They are picked up by plankton. The plankton are consumed by small fish, which of course are eaten by bigger fish. And at least some of these materials show evidence of bioaccumulation as they move up the food chain. The evidence for bioaccumulation of plastics is not nearly so clear as it is for methyl mercury or for PCBs, but the evidence is beginning to come in. And when we eat seafood, we then consume whatever plastics are in the seafood. So here's a map from our cartoon, I should say, from our colleagues at Woods Hole, which presents the complex distribution of plastics in the ocean and makes the point that on the right-hand side here, the slide makes the point that chemicals that go into the ocean tend to get vaporized in the tropical regions where the oceans are warmest, carried through the atmosphere, and then they precipitate out at the poles, at the North and South Pole, where everything is colder. And for that reason, concentrations of persistent pollutants like PCBs and brominated ethyl, polybrominated diethyl phenols that are in plastics accumulate to high levels in the polar regions and disproportionately expose indigenous populations there who rely upon marine seafood as a major source of their diet. And it's through diet that these chemicals get into people. So John Stegeman, this is the JS up here, said that a healthy ocean is foundational for a healthy planet. A healthy planet is foundational for healthy people. And with that, I'll close. I'll stop sharing my screen, and I will introduce my colleague, Dr. Maureen Cropper, who will talk about the health-related economic costs of plastic.
Oh, thank you very much, Phil. What we've done in chapter 5 of the report is to quantify and value some of the health effects that are associated with plastics production and also plastics use. In the case of plastics production, we've quantified occupational hazards to plastics workers and also the health effects of local air pollution from plastics production, from the fossil fuels that are burned to produce plastics on fence line communities. The figures I'm going to show you are global figures. They're based on estimates of where plastics production is taking place around the world. We've also quantified and monetized the damages of the carbon dioxide emissions, which you've heard about already, the 2 billion tons per year of CO2 equivalent that's being released when plastics are produced. When it comes to plastics use, we've examined the health impacts of toxic chemicals that are found in plastics on all-cause mortality, on IQ loss, on coronary heart disease, and stroke. And I'm going to tell you about impacts for 3 toxic chemicals, all endocrine disruptors. The first is DEHP, which is a phthalate that's used in industrial food processing and food wraps. Then PBDE, which is a brominated flame retardant. It's used in furniture and has been used in children's clothing. And finally, bisphenol A, BPA, which has been used extensively in food packaging. When I talk about the damages from these substances, our estimates are for the United States. To estimate the effects of these endocrine disruptors on health, we need dose response functions that, for example, relate BPA to health outcomes, but we also need measures of BPA in the general population. So the National Health and Nutritional Examination Survey in the US provides us with estimates of the levels of BPA, DEHP, and PBDE in representative samples of the general population. So what you're seeing in this slide, on the left-hand side of the slide, are estimates of the global damages from plastics production in the year 2015. All of the damages are in 2015 international dollars. And as you can see, they sum to about $600 billion. If you look at the first 3 boxes, these are impacts on production workers, people who are producing plastics in factories, including impacts of accidents and injuries, exposure in factories to particulates and gases, and also specifically to benzene and formaldehyde. We've estimated these effects by getting estimates really of where plastics are being produced, the number of workers involved, which in 2015 was about 107 million workers, and using information from the Global Burden of Disease Project on occupational deaths. So as you can see, our estimates here are approximately 10,400 deaths due to accidents and injuries, over 18,000 due to exposure to particulates and gases, and almost 3,000 due to benzene and formaldehyde exposure. So in total, about 32,000 deaths. This is what we could quantify. It's not the sum of all of the damages. You can see that we've actually valued each of these deaths. And what we've done here is to follow the World Bank in valuing lives lost using the value per statistical life. This is the sum of what people would pay for small reductions in their risk of dying that together would sum to 1 life lost. We've taken estimates of the value per statistical life, the VSL, from OECD countries. The estimate for 2015 is about $3.8 million. And then we've transferred that amount to all other countries in the world, including the US, based on per capita gross national income. So what you can see here, if you add up the dollar amounts in the first three boxes, is what we would call the welfare cost of these three types of deaths, equal to about $40 billion in 2015. When you go to the fourth box, you're looking at the impacts of all of the fossil fuels that are burned to make plastics. We've heard about the magnitude of fossil fuels that go into plastics production. About 87% of all those fossil fuels are actually being burned for energy. So in 2015, about 44% of the fossil fuels that were burned were coal, 40% were oil, 8% were natural gas. And the fine particles that are generated directly when these fuels are burned and indirectly when NOx and SO2 form secondary particles, those are what we're trying to capture here. We use the intake fraction approach and dose response functions from the global burden of disease. And we estimate that about 159,000 deaths were caused by the burning of fossil fuels to produce plastics in 2015. About 30% of those deaths occurred in China, and another 47% actually occurred in other parts of Asia, because this really reflects where production is occurring. If you add up those four boxes in terms of the welfare costs of the deaths, we're talking about $250 billion. You also heard actually both from Sarah and from Phil about the magnitude of the greenhouse gas emissions that occur when those fossil fuels are burned. And that amounts to about 2 gigatons, 2 billion tons of CO2, which in 2015 was approximately 4% of the CO2 equivalent generated worldwide. So to value those damages, we've turned to the US EPA's social cost of carbon. The social cost of carbon is measuring the value of damages from emitting a ton of carbon dioxide today, looking at the damages, the effects on climate, the effects on human health, agriculture, sea level rise, and other effects that will occur in the future. EPA currently estimates that the damages from emitting a ton of CO2 today are approximately $200 per ton. The value we get here for the CO2 emitted in 2015 dollars is over $300 billion. So you add all of these up, you've got damages of $600 billion. If you look now at the, here we are. If you look at the impacts here on the use or health damages associated with the use of plastics, as I said, these are just for the US, and for a single year in 2015 dollars, they amount to approximately $675 billion. So how do these break down? If you look at the first box, which refers to deaths associated with DEHP among people 55 to 64 in the year 2013, this is an estimate of over 45,000 deaths. It's due to research by Leo Trisandi and colleagues who've estimated these based on epidemiological studies using, data from the National Health and Nutritional Examination Survey. When we value these deaths using a value per statistical life of $5.4 million, we have almost $250 billion of welfare damages. Moving on to PBDE, the estimates here for PBDE are based on studies that link levels of PBDE in the cord blood of pregnant women to intellectual damage, lost IQ points in their children. So their children are followed the impact on IQ tests suggests that for the 2010 birth cohort in the United States, based on PBDE levels measured among women of childbearing age, and in 2010, that actually 10 million IQ points were lost in that birth cohort, which means there will be reductions in lifetime earnings for these children. We estimate these, we take their present value, and this amounts to about $200 billion, which interestingly is just a little over 1% of US GDP in the year 2010. So significant impacts on children's IQ. The last box that you're looking at here represents exposure to BPA. So again, there have been several epidemiological studies that have found links between NHANES cohorts and coronary heart disease, the prevalence of coronary heart disease, and the incidence of stroke. When we look at the prevalence of CHD and the incidence of stroke in the US population in 2020, we estimate based on these studies that about 7.6% of these conditions could be attributed to BPA. The dollar numbers that you're seeing in the box, the $166 billion for coronary heart disease, the $62.4 billion for stroke, represents both cost of medical treatment, but also for those people who died, among the 7.6% attributable to BPA, we look at the welfare cost of those deaths. If you add these three boxes up, they sum to $675 billion. That represents the impacts of 1 year of damages. What we haven't been able to quantify and value are the last two boxes at the bottom of the slide on the right-hand side. The inhalation of nano and microplastic particles, which you've heard a lot about, are not effects that have been well measured and quantified. Also, ingesting plastics through the food chain, this is also difficult to measure and, frankly, to quantify and value. So the numbers that you're seeing here, the $592 billion and the $675 billion, which add to more than $1.2 trillion, is really a lower bound estimate on damages, and this would represent a single year's damage. So I will now pass the baton on to my colleague, Adatun Mustafa.
Thank you, Maureen. Please confirm you can hear me.
We can hear you.
Yep.
Please confirm you can see my screen.
Yes.
Yes, we can see your screen.
Thank you. I'm pleased to be talking about the social and environmental justice issues that are associated with plastics. And what we have done in this chapter of the report is to look at two main issues: the unequal access to information and roles in decision-making, and also unequal distribution of burden on certain groups and people. These are the people that have little contribution to the pollution caused by plastics, but they have the least political power to address them. As Professor Ladrigan and Professor Dunlop have highlighted in their presentations, the impact of social and environmental justice issue associated with plastics actually comes from the production stage. And what you find is that occupational hazard associated with mining and drilling operations and affects workers in this industry. Also, illegal discharge into the environment has resulted in soil and water contamination for population living around these facilities. And this is escalating issues that are already bad in such environments, such as pollution, air pollution, and also resource and habitat loss. Professor Ladrigan has talked so much about the health impact to human. But one of the things you also find is that among indigenous communities, coastal communities, women, children, people of African descent, informal waste pickers, you find out that the production of plastic from mining operations and from petrochemical refinery is actually compounded the inequalities in terms of housing, education, environment, and health care. And from production, addition of chemicals during transportation is another stage where you have social and environmental injustice rather, on people concerned. An example is the vinyl chloride train derailments in the US in recent times. The communities that were the local community, the first line communities that were affected are the ones that are paying the price, that are unaccounted for in the artificial low pricing of plastic, because all these exposures are not factored into the pricing. And these are things that when we are looking at the solution for social and environmental justice, we will need to address. During recycling, exposure to chemicals, hazardous chemicals, is very rampant, especially in low and medium income countries where the informal waste pickers do not have necessary protective equipment while they are doing this work. In some of the photos shown in the slide presented by Professor Ladrigan, you find children around areas where plastics are being recycled, or transit area where they are collected. And these children, their playground is close to this, and they're exposed to chemicals that can leach into nearby water bodies. And also from use, you find that less affluent communities, where there is no alternative, where they have less resources to and access to even alternative to plastic, the market penetration of plastic, styrofoam packaging materials, and food materials are increasing. And these are things that are exposing them to microplastics compared to affluent communities where possibly alternative are available for them. And you will find out that especially in a place like Nigeria and other parts of Africa where population growth is high and urban slums are increasing, you will find the plastic, because solid waste management is very poor, you will find the plastic product clogging drains and water bodies. In certain instances, during rainy season, when you find almost a whole community market flooded, and you will see plastics flowing around. All those photos are circulated on social media. Also, during disposal, There is a lot of social and environmental injustice in disposal. One is the fact that there are still instances while plastic waste are transported from the global north to global south, where labor is cheap and where regulations are not very stringent, and people are exposed to these plastics. Sometimes, oftentimes from open burning and incineration, the ash and the way they are even managed. The standard being used in these places are quite different from what we'll obtain in the global north. So, in addition to human health risk, also the loss of ecosystem services that is associated with plastic needs urgent attention. We're talking about plastic in ocean, almost all the water body that could be major source of revenue for tourism. You find all of them polluted with waste plastics. And you find many of them also clogging waterways. These are issues that the community are grappling with, and they are losing their economic and source of livelihood because of all this plastic waste. So any solution that we are proposing to address social and environmental justice have to address issues related to unequal burden that the global people in the global south and fence line communities and also small states island and also disenfranchised communities even in the global north. Like you can see in the picture on the left, East Palestine in Ohio in the United States, you can see a plume, black plume, rises over it during to the derailed Norfolk Southern train that was carrying the vinyl chloride earlier this year. The photo in the middle here is an informal waste picker transit storage in parts of Nigeria. This mountain of plastic waste are kept there for days, and rain fall on them. People get exposed to them. The whole area where these are stored are unsightly and not a place where people should be living. But these are things that these informal waste pickers have to go through. On the right-hand side, practically most drainage, open drains, you will find single-use plastics clogging them. It is very rampant because exponential population growth is happening in low and medium income countries, and infrastructure is not keeping pace with it. So these communities bear disproportionate burden of single-use plastics, which they do not produce in country. And these are issues we need to address when we are talking about solution. Of course, there are solutions that works and which we all need to talk about, and governments need to adopt both nationally and even globally to ensure that countries that do not have resources to be able to implement those solutions on their own will be supported. One of such solutions is first to close the tap before we start mopping the water, the water on the floor. Let us reduce the source of plastic in terms of production. Professor Dunlop has talked extensively on that. We cannot continue in the projection of the amount of plastics that will be produced and expect the downstream, people in the downstream, who are bearing the disproportionate burden to continue to cope. We also need to hold the producers accountable. It is very important that the artificial cost of plastic that we currently have now, that does not bear the cost, the health costs, and other social burden that are borne by the impacted community, it has to be factored into the pricing. There also has to be the right for the people that are affected by plastic pollution to have access to the right information and to be at the table when the decision is being made, whether it is about siting of facilities related to plastic production or related to recycling or disposal of plastic. There should be transparency, there should be access and rights to information for vulnerable people. The full economic and social cost estimation, like I've mentioned earlier, has to be provided. Extended producer responsibility has to come into play. Let what we advocate in waste management, that anyone producing the waste is responsible for managing the waste from cradle to grave. Let it also happen in terms of plastic. In terms of sector-specific examples, one is about, and this has to be state-specific, in terms of production, there should be equitable siting. It's been found out that most of the facilities for mining and for production of plastics are located in different geography among vulnerable population without adequate safety measures for them. This has to be addressed in the production stage. Another important state-specific solution in the use stage is for us to invest in alternative and to make them affordable and accessible worldwide. It is to spend more fund in looking for local alternative to plastics, especially single-use plastic, and where we can find alternative to other form of plastic. We need to work with local knowledge and look at what is available locally so that we can also reduce our carbon footprint. Not a situation where we talk about alternatives that are not manufactured in the geography, and then there's a lot of transportation and trade imbalance between countries simply because we are asking them to move away plastic. We need to work with local knowledge and transfer knowledge to make alternative affordable and accessible in all parts of the world. We need to also restrict toxic plastic imports into countries. I think that is something that is urgent, is a low-hanging fruit. There is already regulation on transportation of hazardous waste. We need to bring plastics in because it is indeed an hazardous item. A situation where people in Asia, people in Africa are having to deal with the plastic waste from global north has to stop. There should be ban on open burning of plastics. The health impact is huge. It is also exacerbating climate change. It is rife in low and medium income countries to find open burning when there is no alternative or incinerators that are not working effectively. There should be a ban on this. Acknowledging and addressing societal role in solution also need to include a just transition for both the people working in industries associated with plastics, communities, vulnerable communities that are affected, and informal waste pickers. We also need to have a restitution for societal loss. It is only fair that people who do not contribute to manufacturing of plastics and the pollution that are bearing this disproportionate burden, they need to be compensated, and their livelihood, alternative livelihood, need to be provided for them where their water bodies have already been polluted, and those that engage in tourism can no longer afford it. These are some of the things we need to address, and the global treaty need to come clear to also include science, use science as the basis of any decision making. When Professor Cropper was talking, you could find out that the statistics she was using to estimate the economic cost of plastic pollution is mainly from US. If you go into literature, compared to the number of literature you will find in global north, there is no research funding for plastic-related issue in global south. We need to address this. Nobody should be left behind. The people bearing the disproportionate burden do not have the economic and political power to address them. We need to be their voice and support them to get justice. I will hand back to you, Professor Ladrigan.
Thank you, Adatun. If you could stop sharing your screen, and we can see everybody. So I'll just wrap this up by saying a few words about the Global Plastics Treaty. First, the background. The Global Plastics Treaty is proceeding under the auspices of the United Nations, specifically under the auspices of UNEP, the United Nations Environment Program. It was authorized in March of 2022, so about a year and a half ago, by the UN Environment Assembly, called UNEA, and UNEA instructed the world's nations to move forward to draft a treaty to end plastic pollution. That's the wording. The negotiations are on a fast track, which means that they intend to wrap up drafting the treaty a year from now, by the end of 2024. An intergovernmental negotiating committee has been appointed. It's already met twice. It met in Punta del Este, Uruguay, in the spring of this year. It met in Paris this June, July, and the third meeting is to take place in about 3 weeks in Nairobi in November. I think the impetus to the Plastics Treaty has been graphically described by Adatun in her remarks. And I think another way to look at it is to say that plastic pollution, the whole problem of plastic, has grown invisibly like a mushroom, while everybody's attention has been focused on the climate. And of course, the climate needs all the attention we can give it, but this problem of plastic and chemical pollution, which is tightly linked to climate change, of course, because it all comes from fossil fuels, has been growing and worsening while the climate crisis has preoccupied all of our attention. As I said earlier, our Monaco Commission's strongest recommendation in regard to the Global Plastic Treaty is that it must have as its centerpiece a global cap on plastic production. In other words, we just cannot afford to double plastic production by 2040 or triple it by 2060. That is simply not sustainable. Now, of course, opponents of a cap, which means the fossil fuel industry, are going to push back. They're going to say, oh, we can capture the used plastic. We can do better recycling. Well, you know, that sounds good. In principle, of course, we all agree that recycling is a good thing. But the problem is that plastic recycling isn't working. Current day fossil fuel-based plastics are so laden with toxic chemicals, and they're so heterogeneous with so many different chemicals in them, that they just can't be mixed together to make recycled material. It's just not working. And therefore, the only way to control the plastic crisis is to do what we in public health call primary prevention and cut it off at the source, restrict the use of plastic manufacture. Now, please note, I didn't say ban plastics. That would be foolish. All of us know that plastics are essential. Myself, as a medical doctor, I can think of so many things in medicine: intravenous bags, endotracheal tubing, endoscopes. So many uses of plastic in medicine are essential. But we need to distinguish. We need to be smart about this. We need to be intelligent. We need to distinguish between essential plastics and what I call stupid plastics. And stupid plastics are things like plastic bags that have already been banned in countries like Kenya and Rwanda, or plastic straws that have been banned in a number of countries. Throwaway items that the plastic industry had designed specifically to create a market for the fossil carbon that they can no longer burn to warm the planet. And so the plastic treaty is something that we all need to keep an eye on. Just a few minutes ago, I sent around a link in the chat to an editorial that our group published a week ago in Lancet, explaining why the plastic treaty is needed and what's needed. It's only about 1,200 words, a quick read, and I think it'll give you a quick summary of where we stand with plastics. We don't have much time left, but we have a little. So at this point, I'm going to open it up for questions. I think we have one of the staff from CUGH on the line. If that person can monitor the questions, we're all here, and my panelists and I will turn on our cameras so that we can see who you are. Sarika, are you going to keep an eye on the questions for us?
Sorry, can you repeat?
Will you, if let me know if there are questions, please, and we can direct them to the appropriate member of the panel.
I don't see any questions in the
I think I see a hand from Maureen Cropper.
I was going to say there actually is an excellent question in the chat from Lisa Thompson, who asks about measuring human exposure to plastics, which is, I would say, the big problem in actually figuring out what the social costs are. So let me start by saying that when we did our analysis, we focused on substances that leach from plastics and don't have really many other sources of exposure. So, we can measure PBDEs, we can measure BPA, and we focused on those substances, and based on production statistics and the supply chain, these are things that people are getting from plastics. You raise the question, which is very good, when you look at, phthalates, are people getting them primarily through ingestion or dermal absorption, or are they getting them from inhalation? There are some studies that are trying to disentangle these impacts. Not a lot of them, quite frankly. And you also raise the issue of when, plastics are actually being combusted at the end of the life cycle. How do we know what people are inhaling from plastics versus other substances that are being combusted? So the answer is that this is something that really is an active area of research, but we need to know a lot more about. And I don't want to say the sad thing is that what you can study are substances that people, how shall I put it, have known to be dangerous for a long time, and therefore we both have at least in countries where there are biomonitoring surveys, and there aren't a lot of those countries, we know something about what exists in the human body, and we can study its effects. As Sarah mentioned, there are over 10,000 chemicals and plastics whose impacts we unfortunately don't know very much about. But the issue of measuring exposure is really key, and it was a very good point to raise.
If I could just add to that, Maureen, thank you. What's clear to us is that there is way too little independent pre-market testing of all these different chemicals. And even then, when you do the pre-market testing, it's in animal models and tissue culture, which do not reflect the longevity of human beings nor the complex disease states that they develop, whether it's diabetes or neurodevelopmental disease or loss of IQ points and the such like. So on the one hand, before market, we don't know what's been added to the plastic, and we don't know whether or not it's safe. So we need far better testing. But the other side to the coin, which we think is absolutely essential, which does not exist for any industrial chemicals, it does for pharmaceutical chemicals and drugs, which we deliberately prescribe and put in our mouths, and it does for food. But we have no post-market human biomonitoring that's formal across all populations. We see it in the NHANES study in the United States. That's the National and Health Nutrition Examination Survey. There's some biomonitoring in Europe, but where we probably most need it in the countries that Atatürk has outlined and the fence line communities, we just don't know. But I'll tell you, whenever we look, we find them. And this is coming to the fore with suspect screening for chemicals that we don't know whether or not they're there. And whatever we look for, we actually find. These chemicals should not be in us. And the sure way to stop them is to reduce the plastic production. And another part of the treaty will be to ban the toxic chemicals. So there's a lot of work in that space that's needed as well. When you think about it, plastic's got only about 150 different functions, and yet there are thousands and thousands of chemicals that are used to make it. We need to simplify it. So that's another call for the Global Plastics Treaty. And if I could add to that, Phil, the other real element for the treaty is to have a very strong science policy interface, both to shape the specific content of the treaty, as well as to do all of the updates and the monitoring as we go forward. We're going to need appendices for the sorts of chemicals we want to ban. We've got to get the definitions right, and we've got to get countries fully committed so that it is obligatory and that we have legally binding so the treaty is actually legally binding rather than just optional, because if it's just optional, it's not going to happen. And this is very crucial.
Thank you. And I think we're coming to the end of our time. So I want to thank all of our panelists. I want to thank all of you in the audience. And I want to say in conclusion, basically echoing a message that Keith Martin, the Director General of CUGH, put in the chat box, that the political choices are going to determine if the plastic challenge will be addressed. We know how to control pollution. We've reduced air pollution by 77% in countries that have strong air pollution control laws. We know how to do it. The question is going to come down to whether we have the political will to do it. Can we resist the intense pressure that the fossil fuel industry is going to put on the international negotiations? So I will close the session here. I understand that there's a superb session on pollution in the Amazon following, for those who have time to stay on. And on behalf of CUGH and all of us, thank you very much. Good night.